like 3 sections to go over. Okay, we are doing systems of equations, and today we're looking at graphing systems of equations. A system of equations is when you have 2 or more equations using the same variables. So we're going to put 2 lines on the same graph. The solution is the ordered pair that works for both equations. So if I plug the x and the y value in, they would create a true statement for both equations. The solutions are also the ordered pair where those 2 lines meet. So this example on the left, this is an example of a system that has 1 solution. I don't know what's going on. This solution, according to this graph, is at the point 2, 2. So those 2 lines meet at the point 2, 2. This is called a consistent system. A system with equations, or a system with solutions, is a consistent system. In the middle, we have a system that has no solutions. This is a set of parallel lines. What do you know about the slope of parallel lines? Same slope. And because those lines have the same slope, they both rise and run the same amount every time. So those 2 lines will never meet, never cross. There will never be a solution that works for both equations. This is called an inconsistent system because it has no solutions. And on the right, this is a system that has infinitely many solutions. Have you in the past used the letters IMS, infinitely many solutions? You can just write many solutions, many. You could write the infinity symbol for infinite solutions. This happens when the 2 equations are the same line. So they have the same slope and y-intercept. It's many solutions because this point is a solution, and this point, and this point, and this one, and this one, and this one, and this one, and this one. There's an infinite number of points on that line that works for both of them. Because there are solutions, it is called a consistent system. When it asks us to decide if an ordered pair is a solution to the system, remember that the ordered pair is an x value and a y value. We need to plug the x value in, plug the y value in, and see if it creates true statements. So in this first equation, we're going to use 1 in place of our x. We're going to use -2 in place of our y and see if it makes a true statement. 2 times 1 is 2, plus a -2. What is 2 plus a -2? So 0 does equal 0. That is a true statement. So far we're good. But we also need to test this point in the other equation. So we've got -1 plus 2 times -2. We need to see if that equals +5. -1 plus a -4. Does -5 equal 5? No. So is this point a solution? No. It has to work for both of them, not just one of them. It has to work for both. So on your own, I would like you to try example 2. 4 in place of the y, I put 1 in place of the x. I ended up with 4 equals 2, which is not a true statement. Do I even need to take the time to plug it into the other equation? No, it doesn't work for one of them. That means it is not a solution. Don't do more work than you need to do. Once you get a no on one of the equations, you're done. Move on. Okay, I'm going to show you how to graph by hand. I'm going to show you how to graph using the graphing calculator, and I'm going to show you how to graph using Desmos.com. and then I will let you decide which method you would like to use. There's positives and negatives to graphing. Graphing is an easy way to visually see where the two lines meet, where that solution point is. The negatives of graphing are, if you don't use a nice straight edge, it might be hard to find the exact point where the lines meet. If you are not super accurate in your graphing, it might be difficult to find where they meet. And then some systems just don't have solutions that are easy to find on a graph. This particular system is set up perfectly for graphing. So I'll graph the top equation in purple. It's set up perfectly because it's already y equals mx plus b. So this equation, we're going to start at 1 on the y-axis. And our slope is 1, so up 1, right 1. And I would use a nice straight edge if you could. I may even use a ruler to make this nice and straight. Then we need to graph the second equation. This one starts at 4 on the y-axis and has a slope of -2, so down to right 1, down to right 1. And I found that they met right here at this point. That solution is the point 1, 2. You need to write your solution as an ordered pair. Using this same system, I'll show you how to do this on the graphing calculator. On the graphing calculator, you push the y equals button, which is the top left button, the left button underneath the screen. The first equation goes in y1, the second equation goes in y2, and then you can graph both of them at the same time. The cool thing about the graphing calculator is that it does the graphing work for you. The bad thing is you have to have your equations in slope-intercept form in order to plug it into the calculator. So x plus 1. X is the button right next to the green alpha button. I just highlighted it in red. So x plus 1. Go down to the next line. -2. On a graphing calculator, when you're using negative, do not use the minus button. There's a negative button down here next to enter. -2, the x button plus 4. To actually see these on the graph, I push the button that says graph. And those steps are written on your notes. It says calculator steps. Y equals, first equation goes in y1, second equation in y2, push the graph button. If the graph looks funny, like sometimes someone else used the graph, like if you're using an actual handheld calculator, but if necessary, you can push the zoom button in the middle and then number 6, and that resets it to a -10 to 10, -10 to 10 window. So here's that graph that we just did. And you can see on here that they meet at the point 1, 2. Now, one of the things I don't like about the graphing calculator is that that screen is relatively small, so it's hard to see exactly where those points meet. There is a way on the graphing calculator to have the graphing calculator tell you exactly where they meet. If you're interested in learning how to do that, maybe because you have your own graphing calculator, let me know. I can always record a video about how to find the point in the graphing calculator. Okay, this next one, let's do by hand. What do we need to do on this first equation to get this ready to graph by hand? We need to get y by itself by subtracting 2x. So that's the equation that we're actually going to graph. And I'm going to get the second equation ready as well. What do we need to do in the second equation to get this ready to graph? Subtract 3x. And then divide everything by -2. That will give us y equals +3/2 x minus 2. So now that I have both of those ready to go, Pause the video, try graphing both of those equations on the same graph and see where they meet. Once you get those two equations graphed, you should see that they meet at the point 2, 1. Now I'm going to show you how to do this using Desmos.com. So here's the address, desmos.com, since I don't think you can see that on my little bar when I type that in. When you go to Desmos.com, at the very top, there's a button that says Graphing Calculator. And I know it might be kind of hard for you in class to see this screen, but what I love about Desmos is you can type this in the form y equals mx plus b. You can also type this in whatever form this equation is in. So our original equation said 2x plus y equals 5. So right here in this box, I can type in 2x plus y equals 5. And then it just graphed that for me. Then you click on the next line and you type in 3x minus 2y equals 4, and it graphs that one for you. You don't have to rearrange the equation in Desmos at all. Then you can take your mouse and hover over this point where they meet, and it tells you the coordinates of that point. That point is 2, 1. So the nice thing about Desmos is it puts those graphs on there exactly in whatever format the equation is in and tells you where they meet. Now, on the test or on the quiz, you are going to have to put these on the graph. So you do need to know how to put them on the graph. If you use Desmos, you could probably use this to see that the y-intercept is right here at -2, and then I go up, let's see, up 3 over 2 to get to the next point. So you could use Desmos to help you get that on the graph. And I'm fine with you using Desmos in this class. Future classes may not be fine with you using Desmos, but in this class, I am okay with you using Desmos. So we are actually going to use Desmos to help us with these last two. So I'm just going to, and you can like X these out. There's a whole bunch of features in here. So I'm going to X these out and do new ones. 3x minus 2y equals 6. So there's my green line that I just made. My next one, 6x minus 4y equals 12. What just happened? My line was green, now it's purple. Green line, purple line, green line, purple line. They're the same line. And the same line means that there are many solutions. Anyone want to take a guess what the next one's going to be? Probably no solutions, but let's test that theory. I actually reused the same equation. 3x minus 2y equals 6 was the first equation. The second one is y equals 3/2. And in Desmos, if you type 3 divided by 2, it will put it into a fraction for you. You do have to hit the right arrow to get out of the fraction to finish writing the rest of that. And we have parallel lines, which means no solutions. On your assignment, I am okay with you using Graph by Hand, Graphing Calculator, or Desmos. It is a worksheet, so virtual learners, feel free to use those technology features and then just write your answers on a piece of paper. The PDF of the worksheet is available in Schoology.